variable optimization along with the equality constraints, right? So first thing, what is new here? There are more than one equality constraint, right? So this is one thing, and the second thing is that to determine the optimize the value of fx, that is the given objective function, is maximum or minimum. So till now what we were given, no, in example only we were given maximize the objective function, minimize the objective function with this equality function. But here I've taken a problem in which they haven't given us anything. They have told us to optimize this NLP, and they have given us the two constraints, and they have told us, or they have asked us to say whether the optimized value of z is a minimum value or a maximum value, right? So no, the question is solve the non-linear programming problem. Optimize z is equal to 4x1 square plus 2x2 square plus x3 square minus 4x1 x2 subject to constraints x1 plus x2 plus x3 is equal to 15. Then we have twice of x1 minus x2 plus twice of x3 is equal to 20. Then we have x1 comma x2 comma x3 greater than or equal to 0. So this is the numerical. Also find the optimized value of fx is maximum or minimum. Right, so this is the numerical that they have given. Now what we are going to do is we are going to start with very simple funda. Yesterday's only method, only the last part or the later part is going to change. Otherwise, all is going to remain the same only. All right. So what we have here is we have f of x, which is 4x1 square plus twice x2 square plus x3 square minus 4x1 x2. So we are having this. Then we are having the constraint which can be written as g1x, right? So which is x1 plus x2 plus x3 minus 15 is equal to 0. So this is the equation that we have. We also have g2x, which is twice of x1 minus x2 plus twice of x3 minus 20 is equal to 0, right? So yesterday we have seen this particular g1x, g2x are nothing but the constant. Now what we are going to do is we are going to frame out the Lagrangian function. Lagrangian function, right? So it is given as f of x1 comma x2 comma x3. Yesterday we have seen we had only one constraint, so we had used only one Lagrangian function, that is lambda 1. But now here there are how many? There are two constraints. So what we are going to do, we are going to use two Lagrangian functions, that Lagrangian constant, that is lambda 1 and lambda 2, right? So what we can write with yesterday's knowledge is that it is 4x1 square plus twice of x2 square plus x3 square minus 4x1 x2 minus lambda 1 x1 plus x2 plus x3 minus 15 minus lambda 2, which is twice of x1 minus x2 plus twice of x3 minus 20. Right? So I'm hoping that you have understood this. So this is the nothing but this is the Lagrangian function, which is the function of your x1, x2, x3, lambda 1 and lambda 2. Right? So I'm hoping that you have understood this. Right? So what we can do next is now. Now yesterday we had seen when we have a single constraint. So the necessary conditions yesterday were what? Necessary conditions or the conditions that we particularly followed were what? It was dabba l upon dabba x1 must be equal to 0, right? Then we have seen dabba l upon dabba x2 should be equal to 0. Also dabba l upon dabba x3 is equal to 0, right? Again yesterday with respect to this, what we have seen, we yesterday this condition we have written, right? So dabba l upon dabba lambda is equal to 0, but now here we have two lambdas, right? So here it will be dabba l upon dabba lambda 1 is equal to 0 and dabba l upon dabba lambda 2 is equal to 0, right? So these are the necessary conditions, right? So now what we have our L, right? So I'll be writing L here so that we can do the this particular thing. The derivative, partial derivatives can be taken up in a good manner. So 4x1 square plus twice x2 square plus x3 square minus 4x1 x2 minus lambda 1 x1 plus x2 plus x3 minus 15 minus lambda 2 twice of x1 minus x2 plus twice of x3 minus 20. So will have to take the partial derivative of this L with respect to x1, x2, x3, lambda 1 and lambda 2. So let's start, right? So therefore dabba L upon dabba x1 can be written as, so it will be 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2, right? It is equal to 0. We'll be putting this equation 1, right? So I'm hoping that you are getting this. It is easy, right? Similarly, the partial derivative of L with respect to x2 can be written as dabba L upon dabba x2 is equal to what? It is equal to 4x2, right? Minus 4x1 minus lambda 1 minus lambda 1 plus lambda 2 is equal to 0. Hoping that you have got this, what how this came. Dabba L upon dabba x3 is equal to twice of x3 minus lambda 1 minus 2 lambda 2 is equal to 0. This is equation number 3. Similarly, we'll have to equate, you have to find out dabba L upon dabba lambda 1, which is equal to now, it is equal to minus x1 minus x2 minus x3 plus 15 is equal to 0. So this is your equation number 4. Similarly, we can move ahead. We can find out dabba L upon dabba lambda 2. So dabba L upon dabba lambda 2 is equal to minus 2x1 plus x2 minus 2x3 plus 20 is equal to 0, and this is our equation number 5, right? Now what is important here, no? I think that you have got how we have got the equations 1, 2, 3, 4 and 5. It is very simple, and if there is any doubt, you can ask, because unless and until you practice, there won't be any mistakes or the doubts that you'll be getting. So let's focus on this numerical first, and then we can think of moving ahead. Right? So now what we want is, now the next step is to find out the values of x1, x2 and x2. So I'll be writing down this step as well here. To find values of x1, x2, x3 with respect to lambda 1 and lambda 2, right? We have to find out the values of x1, x2, x3 with respect to lambda 1 and lambda 2 here. And when we get the final values of lambda 1 and lambda 2, that values can be used to find out what are the values of x1, x2 and x3, right? So solving or adding equation, adding equation 1 and 2, right? So here it is 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. I'll be reconstructing this, making it minus 4x1 plus 4x2 minus lambda 1 plus lambda 2 is equal to 0. So this is to be added, right? So minus 4x2 plus 4x2 will get cancelled. Here you will be having 4x1 minus 2 lambda 1 minus lambda 2 is equal to 0, right? I'm hoping that you are getting this, right? Further, I can write this as 4x1 is equal to 2 lambda 1 plus lambda 2. Further, I can write x1 is equal to 2 lambda 1 plus lambda 2 upon 4. So what I have done is I have found out x1 with respect to lambda 1 and lambda 2. Now focus on your equation number 3. Sorry, we have got x1 right here. So can we find out the value of x2 as well? So x1 I have found out, and if I put the value of x1 in equation number 1, I can get the value of x2 in terms of lambda 1 and lambda 2, right? So just to do, let's repeat this. So I'll be writing for you what is equation 2, or I can write putting value of x1 in equation 1. What is our equation 1? Equation 1 is 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. And what is, I will be putting the value of x1. So what is my x1 value? 8 x1 will be what x1 is? Twice of lambda 1 plus lambda 2 upon 4. Here I can write minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0, right? So here I can write 4 lambda 1, right? Here it will be 4 1 the 4, 4 2 the 8. So 4 lambda 1 plus 2 lambda 2 minus 4x2 minus lambda 1 minus 2 lambda 2 is equal to 0. No? So solving this, what we can get, 4 lambda 1 minus lambda 1 will be your 3 lambda 1, right? 2 lambda 2 minus 2 lambda 2 will get cancelled, and here it will be minus 4x2 is equal to 0. Therefore, x2 can be what? X2 will be 3 lambda 1 upon 4. So what I have done is I have found out the value of x1 and x2 in terms of lambda 1 and lambda 2, right? So now considering equation 3, I will also have to find out the value of lambda 3, right? Considering equation 3, I'll be writing the equation 3. That is 2x3 minus lambda 1 minus 2 lambda 2 is equal to 0. Now this particular equation in itself has x3 and the particularly the variables lambda 1 and lambda 2. So I can directly find out what is the value of x3 in terms of lambda 1 and lambda 2. So it will be lambda 1 plus 2 lambda 2, and therefore I can find x3 is equal to lambda 1 plus 2 lambda 2 divided by 2, right? So I think that you have got this, how we have found out the value of x1, x2 and x3 with respect to lambda 1 and lambda 2, right? So I'll be just writing here the values, reconciling x1 is equal to 2 lambda 1 plus lambda 2 upon 4. x2 is 3 lambda 1 upon 4, and x3 is equal to lambda 1 plus twice lambda 2 upon 2, right? I'm hoping that you have understood how these values came. Now considering equation 3 and 4, considering equation, sorry, 4 and 5, 4 and 5. So what are equation 4 and 5? I will be just writing it for you. Minus x1 minus x2 minus x3 plus 15 is equal to 0. This is your equation number 4. And your equation number 5 is minus 2x1 plus x2 minus 2x3 plus 20 is equal to 0. So this is your equation number 5. Now here you can see, no, here what I can do is I can put the values of, now I know what are the values of x1, x2 and x3. So what I'll be doing, I'll be substituting the values of x1, x2, x3 both in equation 4 and 5, and I can find, I'll be getting two equations in terms of lambda 1 and lambda 2, right? So there are two equations and two unknowns, so I can particularly solve this. So let me put this, equation. So putting, just a second. Putting values of x1 comma x2 comma x3 in equation number 4 was, right? So equation number 4 was minus x1 minus x2 minus x3 plus 15 is equal to 0. So what is the value of x1? The value of x1, value of x1 is minus, it will be 2 lambda 1 plus lambda 2 upon 4 minus x2. Minus x2 is okay, what is the value of x2? The value of x2 is 3 lambda 1 upon 4 minus x3, that is lambda 1 plus 2 lambda 2 upon 2 plus 15 is equal to 0. What I can do is I can multiply it entire equation by 4, multiplying above equation by 4. What I'll be getting? Minus 8 lambda 1. Okay, no, 4 will get cancelled here, right? So it will be minus 2 lambda 1 minus lambda 2 minus 3 lambda 1. Here it will be minus 2 lambda 1 minus 4 lambda 2 plus 15 for the 60 is equal to 0, is equal to 0, right? So solving this equation properly, right? So minus 2, so minus 2 lambda 1, I can write it, for example, 2 lambda 1 plus lambda 2 plus 3 lambda 1 plus 2 lambda 1 plus 4 lambda 2 is equal to 60, right? So now it will be easy. So 2 lambda 1 plus 3 lambda 1 is 5 lambda 1 plus 2 lambda 1 is 7 lambda 1 plus lambda 2 plus 4 lambda 2 is 5 lambda 2, right? So 5 lambda 2 is equal to 60. So this is our first equation in terms of lambda 1 and lambda 2, and it is termed as equation A. Putting, next step, putting values of x1 comma x2 comma x3 in equation 5, right? So equation 5, what we had was minus 2 x1 plus x2 minus 2 x3 plus 20 is equal to 0. तो ये हम लोगों का इक्वेशन नंबर 5 था. तो इसमें अगर हम लोगों ने पुट किया माइनस 2 इंटू 2 लैम्डा 1 प्लस लैम्डा 2 अपॉन 4 प्लस x2 क्या है 3 लैम्डा 1 अपॉन 4 माइनस 2 इंटू lambda 1 plus 2 lambda 2 upon 2 plus 20 is equal to 0, right? So what we can do is we can particularly again multiply the same equation by 4, and what we can get is minus 4 lambda 1 minus 2 lambda 2 plus 3 lambda 1. तो 4 से मल्टीप्लाई किया है तो यहाँ पे 2 रहेगा. So here it will be minus 4 lambda 1 minus 8 lambda 2, and 4 से multiply it, 24 the 80, so plus 80 is equal to 0. So what we can write here is, no, uh, 4 lambda 1 minus 2 lambda 2 plus 3 lambda 1 minus 4 lambda 1, 3 lambda 1 plus 4 lambda 1 plus 8 lambda 2 is equal to 80, right? So what will be getting, a 4 lambda 1 minus 3 lambda 1 is lambda 1, lambda 1 plus 4 lambda 1 is equal to 5 lambda 1, right? So minus 2 lambda 2 will be minus, it will be plus here, okay. So plus 2 lambda 2 plus 8 lambda 2 is 10 lambda 2 is equal to 80. So this is our second equation with respect to lambda 1 and lambda 2. So solving A and B, so you have two equations and two unknowns. So if you solve this, so you'll be getting lambda 1 value as, lambda 1 value is coming out to be 4.44, and lambda 2 value comes out to be 5.77, right? So these are two very important values. Now that we have got, the values of lambda 1 and lambda 2, can we find out the values of x1, x2 and x3? Yeah, so we can find out the values of x1, x2 and x3. We already know what is the values of x1, right? So what is x1? X1 is x1 is equal to 2 lambda 1 plus lambda 2 upon 4. X2 is equal to 3 lambda 1 upon 4, and x3 is equal to lambda 1 plus 2 lambda 2 upon 2, right? So if you will be solving this equation, so that is, what you will be getting is the values as 3.6625, we getting this value as 3.33, this value comes out to be 7.99, right? So what we have got now, this particular x1, x2 and x3 is the point where you will be getting an optimum value, right? So this particularly is x star. X star can be represented as now 3.6625, 3.33, and we'll be getting 7.99 is the point of getting the optimized value, right? You can even find out what is the optimized value, that is f of x star, that you can directly find out, right? So here f of x star is equal to, what is your objective function? It is 4x1 square plus 2x2 square plus x3 square minus 4x1 x2, right? So you can find out this f of x star, the f of x star, if you found out, it is 91.12, right? But now this 91.12 is z minimum or it is z max, that we are going to find out. We don't know what this 91.12 is, whether it is z minimum or whether it is z max. We don't know because we have been given optimize that particular thing. What is the value of x star? Now what we are going to do is, we are going to start with the procedure in which we are going to get, whether this particular function or whether this particular value z is of a minimization type or a maximization type. We know that z is an, we know that x star is the optimal point. We know that no f of x star is the value that we have got for z is again extreme point, but this is an extreme point related with minimization or maximization, that we do not know, right? So what we are going to do is, now we are going to use the Heisenberg matrix, right? And this is somewhat complex matrix, right? So Heisenberg matrix, this Heisenberg matrix HB is given by O V, V transpose and M, right? So here O is a null matrix. So we are going to find out, these are the four parts of the matrix. So we have to find out what is the, the value of this null matrix. We have to find out what is this V matrix, what is V transpose matrix, and what is the M matrix. So there are different steps of this, right? So, sorry. Okay. So what we are going to do is we are going to use the Heisenberg matrix. There was some overlap that happened. So it is called as HB, which is 0, V, VT, and M. So these are the four parts of it, right? And what we are going to do, we are going to find out each of this part separately, right? So let's find out what is O. O matrix is nothing but a null matrix, right? And it is M by M null matrix, right? Where M is equal to number of constraints, right? M is equal to number of constraints, right? So what are the number of constraints here? M is equal to 2. Therefore, this is 2 by 2 matrix. So it can be given as 0 or O is equal to 0, 0, 0, 0. Right? Now what we have to find out is we have to find out the value of V matrix. Right? So we have to find out this value. So what here we have to consider, we had two constraints, that is G1x and G2x, right? So I can write G1x as x1 plus x2 plus x3 minus 15, and I can write my G2x as twice of x1 minus x2 plus twice of x3 minus 20. So this is already given to us, right? These are the constraints. Now what we are going to do is, we are going to find out the values of the elements of this V matrix, and now this V matrix particularly it will be, I'll be telling you how the values are to be found out. So each of this value I am going to write it. It is very simple. It is dabba G1 upon dabba x1. We are going to require this value. We require dabba G2 upon dabba x2 value, right? And we require dabba G3 upon dabba x3 value, right? So if we find out dabba G1 upon dabba x1, so dabba G1 is equal to 1, right? Dabba G2 upon dabba x2 is equal to 1 again, and dabba G3 upon dabba, sorry, it is G1 only, I'm very sorry. So this is 1 and 1 only, right? So dabba G1 upon dabba x2 and dabba G1 upon dabba x3, if we find out, this is again 1. We would require one more value, that is we require dabba G2 upon dabba x1. We require dabba G2 upon dabba x2, and we require dabba G2 upon dabba x3 as this value. So dabba G2 upon dabba x1 will be what? It will be equal to 2. Dabba G2 upon dabba x2 will be equal to -1, and dabba G2 upon dabba x3 will be equal to 2, right? So now the V matrix here is given as, the V matrix is given as, we have to write these values in this order, right? So here it is 1, this one here, then this one here, and this one I'll be writing here. So this is 1, 1, 1. Similarly, I'll be writing 2 minus 1, and here it is 2. 2 minus 1, 2. Similarly, the transpose of this matrix can be written as 1, 1, 1, 2 minus 1, right? So we have found out, this value, O value we have found out, we have found out V value, we have found out VT value, and then we have found out the value of M, right? Is there any doubt up till now here? Can you put in chat box that we have understood how we have found out the value of a null matrix, V matrix, and V transpose matrix? Everyone put in the chat box if you have understood this or not. right? So some of you are saying that it is understood, so I consider that you have understood this and we can move ahead, right? So what next we have to find out is, lastly, we are going to find out the value of M matrix. Again, it is very simple, right? Just telling you how to find out the value of M matrix, right? So M matrix, for that we require the our complete Lagrangian function. So if you remember, our Lagrangian function was given as L is equal to, it was f x1 comma x2 comma x3 comma lambda 1 comma lambda 2, and it was given as 4x1 square plus 2x2 square plus x3 square minus 4x1 x2. So this is your objective function, and then minus lambda 1 x1 plus x2 plus x3 minus 15, right? And this is, what we have written now was, it was your constraint 1, and then we had constraint 2 minus lambda 2 2x1 minus x2 plus twice x3 minus 20, right? So now what we are going to do is, we are going to require 9 values here. So we are going to require which values that I will be writing, right? So we require dabba square L upon dabba x1 value. We require dabba square L upon dabba x1 x2 value. We require dabba square L upon dabba x1 x3 value. We require the value of dabba square upon L dabba x2 x1 value. We require dabba square L upon dabba x2 x2 value. We require dabba square L upon dabba x2 x3 value. Again, we'll be requiring dabba square L upon dabba x3 x1 value. We require dabba square L upon dabba x3 x2 value. We require dabba square L upon dabba x3 x3 value, right? So all these values we are going to require, right? So how we can write this, it is, only for the first 3 values we will be requiring to take some efforts. After that it is easy. So dabba upon dabba x1, and then it is dabba upon dabba x1. So what is that value? That value will come out to be dabba L upon 8x1, right, minus 4x2 minus lambda 1 minus 2 lambda 2. Is it that value, right? So just a second, I'll be here on this page, it will be leading to a confusion. So what I'll be doing is, I'll be taking in another page where you'll be having these values properly written. Just give me 1 minute. So I'll be just writing. All right, so just a second. So what we require firstly is dabba L upon dabba x1 x1. So this is dabba upon dabba x1, dabba L upon dabba x1. So it is dabba upon dabba x1 of 8x1 minus 4x2 minus lambda 1 minus 2 lambda 2, right? So if we take this, no, we solve this value, so it will come as 8, right? So nextly what we require is dabba square L upon dabba x1 x2. So dabba upon dabba x1, dabba L upon dabba x2. So dabba upon dabba x1, and this will be what? It will be 4x2 minus 4x, uh, yeah, minus 4x1 minus lambda 2 plus lambda 2 equal to, right? So 4x2 minus 4x1 minus lambda 2 plus lambda 2 is equal to, so differentiating it with this partially with respect to x1, the value will come as minus 4, right? Similarly, we can find out dabba square L upon dabba x1 x3 is equal to dabba upon dabba x1 dabba L upon dabba x3 is equal to dabba upon dabba x1, and with respect to x3, what will be the value? It will be twice of x3 minus lambda 1 minus 2 lambda 2, right? So if we no, differentiate with respect to x1, the value will come as 0 only. Similarly, we can move ahead. Dabba square L upon dabba x2 x1. So this will be dabba upon dabba x2 upon dabba L upon dabba x1. So previously we somewhere we have this value. So this is nothing but dabba L upon dabba x1 only. So same value we can picturize, and the answer here will be coming out to be minus 4, right? So nextly dabba square L upon dabba x2 x2. So dabba upon dabba x2 of dabba L upon dabba x2. So this is the value of dabba L upon dabba x2. So differentiating it with respect to x2, what answer will be getting? The answer is 4, right? Similarly, dabba square L upon dabba x2 x3, it is dabba upon dabba x2 dabba L upon dabba x3. So dabba L upon dabba x3 value is this. There is no x2 term here, so the answer will be 0, right? Similarly, dabba square L upon dabba x3 x1 can be given as dabba upon dabba x3, no, so here it is dabba L upon dabba x1, and this value will come out to be 0. Similarly, dabba square L upon dabba x3 x2 will be dabba x3 upon dabba L dabba x2, and this will come out to be 0 again. So lastly, dabba square L upon dabba x3 x3, it will be dabba upon dabba x3 dabba L upon dabba x3, and the value here will come out to be 2, right? So I'm hoping that you have understood this. Now how we are going to write down this matrix is important, right? So again, it is simple only. The M matrix we are going to write the all these values. So here 8 minus 4 0. So this is 8 minus 4 0, right? Similarly, it is minus 4 4 0, right? So minus 4 4 0, right? So it is 0 0 2. So it is 0 0, right? So we have found out the values of all the this thing. So we have found out null matrix, V matrix, V transpose matrix, and now M matrix. Now what we are going to do is we are going to put this value in all these values in this particular matrix, and then we are going to construct one mega matrix, what we can say, or the Heisen matrix that we were thinking of. So let me just write down all these values, right? So what is Heisen matrix? Given by null matrix V, Vt, and M, right? So our null matrix, right? So null matrix was 0 0 0 and 0. Our V matrix, if you remember, right? Just give me a second. Yeah. So the V matrix was 1 1 1, and it was 2 minus 1 and 2. Similarly, the V transpose matrix was 1 1 1, and it was 2 minus 1 2, right? Now the M matrix that we had, so the M matrix was given as 8 minus 4 0, that is minus 4 4 0, 0 0. So same thing if I have to do, right? It is can be shown like this, right? So this is our null matrix, this is V matrix, this is VT matrix, and this is our uh, M matrix, right? Now we have to find out, if the this is maximization or the Z value that we have got is a Z max value or Z minimum value, right? So what we are going to do is, particularly, we have to check, right? So to check, there is a check that is available. So X star value is maximum if -1 M plus N, and it is X star is minimum if -1 M, right? So now here M is your number of constraints, N is the number of variables that are available. So this was equal to 3, this was equal to 2. So here it is -1 raised to 5, and it is -1 raised to 2. So -1 raised to 5 is equal to -1, right? And -1 raised to square is equal to 1, right? So now this particularly tells us if the particularly next thing what we have to do is we have to find out the determinant of HB matrix, the upper matrix that we have got. So now according to this numerical, if it is the determinant is negative, then if if this determinant is negative, so this is negative and this is related with our first condition. The first condition is of what? It is of maximum. So that means that you have got Z max value, right? So if it is positive, positive condition is with respect to what? It is with respect to the minimum. That is our second condition, and then you get Z minimum, right? So if you calculate the matrix of this, it comes out to be 72, which is greater than 0, or it is what we can see, it is positive. Hence Z is equal to Z minimum value is equal to 91.12. So this finishes your numerical.